In our last video for chapter 6, we're going to look at what are called standard conditions and standard states and look at enthalpy changes for those situations. So to begin with, what is standard state? So when we talk about enthalpy, it's good for chemists to have the same frame of reference when we talk about values. So a standard state for gas is if our gas is at 1 atmosphere, and for solids and liquids, it's their most stable form at 1 atmosphere and some temperature, usually 25 degrees Celsius. And for solutions, it's when we have a concentration of 1 molar. And standard enthalpy change is just the change from reactants and products in their standard state. And we give it this little circle or knot. And we can also have the standard enthalpy of formation, which is the enthalpy change for forming 1 mole of a pure compound from its different elements. These elements are in their standard state, and if we have a pure element in its standard state, delta H of formation is 0. So when we're talking about delta H of formations, we have a huge table that tells us a bunch of elements, what their delta H's are. By no means will you have to memorize anything from this table, but again, you will know, like we have seen before with previous tables, you just need to know how to read it. So it tells you what substance we have and their delta H of formation. So let's talk about formation reactions for carbon monoxide. And carbon monoxide is made between carbon and oxygen. And we have to look at what are the standard states for carbon and oxygen. So we go back to the table on the previous page, or appendix 2b in your book. And we have multiple entries for carbon, but you pick the entry where delta H of formation is 0. That's the pure substance. Same thing for oxygen. And where delta F is 0 is for O2 gas. So to make carbon monoxide, it's solid carbon plus O2 gas goes to CO. But we have to balance this. And the product compound usually always must have a coefficient of 1. So that's why we get this funky 1/2 mole of oxygen makes carbon monoxide. Okay? So let's try this with NH3. So if we look at NH3, it's made out of nitrogen and it's hydrogen. So standard state of nitrogen is N2 gas with delta H of 0. Standard state of hydrogen is H2 gas with 0. So it's N2 gas plus H2 gas goes to NH3. But we need to balance this. So we need 1/2 N2 plus 3/2 H2 to give us NH3. For NaCl, we look at sodium. Na solid is our standard state, plus if we look at chlorine, it's Cl2 gas. So to balance it out, it's Na solid plus 1/2 Cl2 gas gets us NaCl. And if we want to calculate the standard enthalpy change for a reaction, it's just the delta H of formations for our products multiplied by the number of moles, and we add up all those values, and we subtract from the delta H of the reactants, always products minus reactants, times the number of moles. And this is something we would have to calculate or look up in our appendix. And so let's do an example problem. So we have pentane, which is a component of gas that burns according to this following reaction. What is the delta H naught of this reaction? Again, here's our formula for delta H naught. Here's all your standard enthalpies of formation. So see if you can figure this out. Alright, let's take a look. So it's the sum of the delta H formation of our products multiplied by their moles. So if we look at our products, we have CO2 gas, which has 393.5 multiplied by 5 moles, plus H2O, which is, sorry, that's a typo. That should be 285.8 times 6, minus pentane, 146.8. We have 1 mole of that, times oxygen, which is 0 times 8, which is also 0. And we should get 3.27 times 10 to the 3 kilojoules per mole. So that's all it is. Not a hard calculation, but that is how you do these problems. And with that, we finish off Chapter 6, moving into quantum mechanics in Chapter 7. So I will see you in that chapter.